Hey everybody, welcome to our asynchronous day. Today is Wednesday, September 23rd. We will not be meeting in class, but you will be following along with our video lesson, and then I've got a couple quick assignments for you to do after the video lesson is done. So those two assignments will be a Google Doc about ions. This is where we talk about protons and electrons and figure out what the charges are. And then we'll do a Google Draw. It's a little drag and drop thing that we're going to do on isotopes. I'll demonstrate those before we get going. So let's start with a little warm-up. And the question here is, which of these five has the most electrons? So at this point, you can pause the video and see if you can figure out how many electrons each of those atoms has. Now notice some of them have charges, which means they may have more or fewer electrons than they do protons. We're going to compare those, and then I'm going to ask you to circle the ions above. So go ahead and pause and try that out, and then I will switch to the camera, and we will go over this. So now we're going to go ahead and try to figure out the number of electrons in each of these atoms. We're going to start with neon because neon is neutral, right? There's no charge here. So if we look at the periodic table, neon has 10 protons. And because it's neutral, it has the same number of electrons to balance it out, right? There's no extra positive or negative charges. So notice how you don't have any extra positives or negatives. So neon is neutral. And again, if it's neutral, the protons equal the electrons. If it's neutral, which means no charge up here. Let's take a look at sodium. Sodium has 11 protons. It is number 11 on the periodic table. Now this sodium, if it was neutral, this sodium would have 11 electrons, right? But it's not neutral. It has a positive 1 charge. It has one less electron, one less negative charge, because we can't add protons, right? We can't make this a 12. So what happened here is we took away an electron, and if you take one electron away from that, you have 10 electrons. Notice how if you take the difference here, right, if you had a bunch of positives and a bunch of negatives and started canceling them out, you would end up with +1 charge, right? An extra charge. That's where the +1 comes from. If we take a look at magnesium, we have 12 protons. That's from the periodic table. This magnesium has a 2+ charge. We have 2 extra pluses, which means we had to take away 2 minuses. We had to take away 2 electrons. So if you took away 2 electrons, again, we have 10 electrons. And notice that when you start canceling out charges, we're left with a 2+ charge, right? +2, 2+. Now, how about the problem asks you to circle the ions? Well, once again, what's an ion? An ion equals a charged atom. Right? So, plus or minus charge. This is an ion. This is an ion, right? Because they have plus charges. Neon is neutral. It is not an ion. All right, let's take a real quick look at this. The other ones. Let's start with neon again. We said 10 protons, 10 electrons. Neon is neutral. Now we have fluorine. Let me just adjust my camera a little bit. There we go. Fluorine has 9 protons if you look at the periodic table. If fluorine was neutral, it would have 9 electrons. But it doesn't. It's not neutral. It has an extra negative charge. It has an extra electron. So fluorine with a -1 charge, again, notice that if you cancel out charges, you're left with 1 negative charge. Oops. And that is where the negative comes from. Let me see if I can move this up a little bit. I'm having trouble with this camera today. All right, let's finish this off. Here I have oxygen with a 2- charge. Oxygen normally has 8 protons. It always has 8 protons. If oxygen is neutral, it has 8 electrons. But this oxygen is not neutral. It has extra 2 negative charge. It picked up 2 more electrons. So it has the 8 electrons that it started with, plus 2 more that it picked up. And as you can guess, we're also at 10 electrons. If you look at the net charge here and they start canceling out, you're left with a negative 2 charge. Okay. Once again, if you circle the ions, this is an ion and this is an ion, because they are charged atoms. They have a negative or positive charge. Can atoms of different elements have the same number of electrons? Of course, they do. Right? Here we just gave you an example of 5 different atoms that all had 10 electrons. They differ in their protons. All right, we'll move on. So now we're going to talk about something called an isotope. Oops. So you might have heard the term isotope. It is not to be confused with ions, though both I words. But isotopes are atoms of the same element, so 2 iron atoms, 2 oxygen atoms, 2 carbon atoms, that have a different number of neutrons. Right? So we're not talking about electrons, we're talking about what's in the nucleus. So here's an example of some isotopes of carbon. So carbon always has 6 protons. Right? If you look at the periodic table, carbon always has an atomic number of 6. So we're going to look at protons and neutrons, but carbon can also have a different number of neutrons. In this case, carbon can have 6, 7, or 8 neutrons in the nucleus. So let's see if we can figure out the mass for each of these three different types of carbon atoms. So once again, periodic table. Well, we're not going to go for the periodic table right now. We're going to give the number of neutrons, right? 6, 7, and 8. They'll tell you this, or they'll tell you the mass number. But we know that carbon always has 6 protons. So if you want to look for the mass of an atom, again, the mass number is going to be the protons plus the neutrons. So in this case, this carbon has a mass of 12. This middle carbon has a mass of 6 plus 7, or 13 AMU. And this carbon all the way on the right is a little bit heavier, has 6 protons plus 8 neutrons, and that gives you a mass of 14. So again, three different atoms of carbon. Right? They're the same in every way, except that one of them is lighter, one of them is heavier, and all 3 of them have different masses. So these are isotopes, atoms of the same element, 3 carbons, different number of neutrons, therefore they have a different mass number. So there's a couple ways to write isotopes, and we've already seen this, one of these ways. One of the ways is called the hyphen notation, and a hyphen is like a little dash. So you would either write the symbol or the name. We tend to go with the symbol because you save a few letters that way. Symbol, hyphen, and the mass number, the protons plus the neutrons. So if you look back at our example, we had carbon with a mass number of 12, carbon with a mass number of 13, carbon with a mass number of 14. And we would write it as C-12, C-13, C-14. And we'd refer to it as carbon 12 or C12, carbon 13 or C13, carbon 14 or C14. That is hyphen notation. This is probably some of the more common ways you'll see it. Another way you might see it is what we call isotope notation. And this one gives you a little bit more information, although it's a little bit extra, because if you have a periodic table, you don't need some of the information it gives you. But let's take a look. You're still going to have the element symbol. You're still going to have the mass number, protons plus neutrons, and they're going to give you the atomic number. Even though if you have the element symbol, you can find the atomic number on the periodic table. Right? So if they give you iron, you know that this atomic number is going to be 26 if you have a periodic table. If they give you fluorine, you can look at the periodic table and know it's going to be 9. So they give you a little bit of extra information that you don't necessarily have to have, but this is how they write it. So again, going back to the example, we had carbon with a mass of 12, 6 protons plus 6 neutrons, and this is the atomic number of carbon, 6 protons. We have carbon 13, 13 protons plus neutrons. Of the 13, 6 of them are protons. This is the atomic number of carbon. And then we have carbon 14, 6 plus 8, right? 6 protons plus 8 neutrons gives me 14. And again, this is the number of protons. This is the atomic number. So notice in this example, carbon, just take a second to look at this. Every carbon has 6 protons, right? Atomic number of 6. Where's the difference? The difference is in the mass. And this is kind of convenient because if they ask you the number of neutrons, you just put a little minus sign there, right? 12 minus 6, 6 neutrons. 13 minus 6, 7 neutrons. 14 minus 6, 8 neutrons. So it's kind of handy to have, but again, you know this, you know the atomic number if you know the symbol. All right, now it's time for you to give it a try. There's 2 isotopes of neon. Neon has an atomic number of 10. One isotope has 10 neutrons, the other has 11 neutrons. Okay? Now that's not the mass, that's just how many neutrons there are. And remember, the mass number is protons plus neutrons. So if I were to write these in hyphen notation, the first isotope would be neon 20. 20 is 10 protons plus 10 neutrons. That's the mass of the first isotope. The second isotope, the other isotope, has 10 protons, because every neon has 10 protons, plus 11 neutrons. 10 plus 11, 21. So neon 20 and neon 21, those are the 2 isotopes of neon written in hyphen notation. And again, symbol, hyphen, mass number, protons plus neutrons. If we were to write this in isotope notation, the first one would look like this. Symbol, neon. Neon has an atomic number of 10 protons, always. And then the top number is the protons plus the neutrons, right? The mass number. The second isotope would be written like this. Symbol, this is neon, always with a atomic number of 10. This one has 11 neutrons, so 10 protons plus 11 neutrons is 21. So once again, you look at this and say, all right, 2 atoms of neon, they both have 10 protons because that's what neon has. Where do they differ? They differ in their mass. This one's slightly heavier by 1 AMU. Why do they differ in their mass? Because one of them has 1 neutron more than the other one. Okay, so this, remember, top number is protons plus neutrons. Notice, sorry, before we leave, notice again, we're not talking about this anymore. This is an average atomic mass. We're going to calculate this average next time. So they're giving you the mass numbers, so we're not going to worry about this. We're just going to worry about this at this point. All right, so let's practice a little bit and see if we can do this. Feel free to pause the video and see if you can figure this out. All right, so now we're going to practice writing both types of notation. First, we're going to start with lead, and we're going to write the hyphen notation first. So the first thing we're going to do is write the symbol, PB, hyphen, and now what goes here is the mass number. So once again, we're going to take the protons plus the neutrons. So 82 plus 126 is 208. So a total of 208 AMU, 208 protons plus neutrons. If I want to write this as isotope notation, it's very similar. Symbol. I'm going to put the mass number, again, protons plus neutrons, on top. And again, they're going to give us that extra bit of information, and that's the atomic number or the number of protons. Now again, if you have a periodic table, you know that, or you can find it, but they give that to you anyway. So that's the total isotope notation for lead 208, and that's how we would pronounce it, lead 208. Let's talk about zinc. Now this zinc has a 2+ charge, but that really doesn't have anything to do with isotopes. Notice it has 2 extra protons, right? We took away 2 electrons. That was about ions. Let's do the hyphen notation. Zinc, again, mass number, protons plus neutrons, 65, 30 plus 35. And if I want to write the isotope notation, zinc, mass number, atomic number. Any isotope of zinc, right, if we had one that had 34 neutrons, you would still have 30 down here, right? It's always going to be 30 for zinc because it always has 30 protons. You might have a different mass number here depending on the number of protons. All right, krypton, actually a thing. Mass number, 36 plus 49, 85. And if I want, that's the hyphen notation, krypton 85. If I want to write the isotope notation, again, symbol, mass number, and atomic number, number of protons. Krypton 85. All right, we'll do a couple more, and then you try it yourself. All right, so this is tin. It's from the Latin estaño. Hyphen notation, SN, hyphen. Once again, we're going to add these together. Mass number, 50 plus 68 is 118. So we have tin, 118. You could have also written it like this, tin 118. The isotope notation will be the symbol, the mass number, and the number of protons or atomic number. So again, that's off the periodic table, or they give it to you here. Sulfur. This is going to be sulfur with 16 protons and 16 neutrons for a total of 32. We will write it as sulfur 32. And of course, every sulfur has 16 protons and neutrons. Or I'm sorry, 16 protons. That's the atomic number. And then xenon, it's a radioactive gas. It's all the way to the right on the periodic table. We're going to add these two together. 54 plus 77. That's the total number of protons and neutrons in the nucleus. Comes out to 131, so we write xenon 131. That's the mass number. And then that's protons plus neutrons, right? Whoops, let me move that up a little bit. If we were to write the isotope notation, we would write xenon 131, and of course the atomic number of xenon, which would be 54. Okay, so again, this is the atomic number off the periodic table, and the top one is 131. I'm just going to draw a little line there, see. And they set it up quite nicely. If you were looking to calculate the number of neutrons, you basically just got to do the subtraction, right? 131 protons plus neutrons minus 54 protons gives you 77 neutrons. So now we're going to look at the assignments that you're going to do as part of your asynchronous day. And first we're going to go to ions, fill in the blank. And we're going to use what we know about ions and electrons and protons to go ahead and work on this. So basically here we're going to say, for example, sodium. We'll do the first one together. Sodium, I'm going to look at the periodic table, and I see that sodium has an atomic number of 11, which tells me it has 11 protons. Now for the mass number, I'm going to see what it says below. It says if the mass number is not given to you, round the atomic mass from the periodic table to the nearest whole number. So in this case, they don't say sodium-23 or anything like that. So we're going to look at the periodic table and see that it's 22.99. So we're going to give it a mass number of 23. So for this whole column, you're going to be looking at the periodic table, rounding the mass to the nearest whole number. How many neutrons? Well, if you look at the neutrons, and you don't have to type the math in here, but if you look at the neutrons, you know that mass number is the protons plus the neutrons. So 23 minus 11, which would give us 12 neutrons. And once again, you don't have to type in the math or do the math. You just have to tell me there are 12 neutrons. 11 protons plus 12 neutrons gives you a mass of 23. Now we look at the electrons. Well, this is sodium with a +1 charge. In other words, it has one positive charge more than the negative charges. So we took away an electron. So notice again, if you look at 11 positives and negatives, we're going to end up with a charge of +1. And this charge comes right off of here. This is sodium with a +1 charge. So you should be able to fill in every square here. There's not that many of them. There's only 12. Some of them have a lot of information. Some of them have just a little bit. Some of them have just the protons and a charge, and you should still be able to figure it out from there. Okay, don't forget to put the symbols here for what element it is. All right, let's go back. I'm going to close this out and go back to classwork. Now we're going to look at the isotope drag and drop. This one's kind of fun. So we're going to take the symbols, hyphens, and numbers to make 6 isotopes that are specified. So all we're going to do here, and there will be one piece left over, we have all these little pieces over here. We have some symbols like aluminum, boron, phosphorus. We've got some numbers. These could be either mass numbers or atomic numbers. And of course, we've got some hyphens. So for example, isotope notation for magnesium with 13 neutrons. Well, again, isotope notation means symbol, mass number, and atomic number. So I pulled these pieces together to make isotope notation. Let's see what the hyphen notation would look like. I'm not going to do it for you, but hyphen notation, I would drag scandium, I would drag a hyphen, and then I would find the mass number here, protons plus neutrons, and drag that over. So you have 3 hyphen notations to make and 3 isotope notations to make. All right, I'm going to put these back. If you have any questions, send me an email, or you can talk to one of your classmates if you'd like, and give that a try. This is due tonight at 6 p.m. since it's part of the classwork you would have been doing in class.